The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Welcome back to another great episode of our Best Practices webinar series with SevenSignal. If you could, please let us know where you are tuning in from today in the questions panel. If you are in the office today, if you're working from home. I am again back in my apartment working from home in Cleveland, where I just looked outside a couple minutes ago and we are starting to get some snow. So super excited about that. We are also joined by Dave Hallis. How are you today, Dave?
I'm great.
Awesome. Great to hear it. And we are also joined by Jim Vada yet again. How are you today, Jim?
Doing well down here in the Cincinnati area. We're getting a couple inches of snow as well. So it's all over Ohio.
All right, awesome. I see a lot of you dropping in where you are joining us from today. We have Peter joining us from Boston. Thank you, Peter. We have Sala joining us from the UK. Thank you for tuning in today. We have Paul joining us from Pennsylvania, waiting for the snow. Thank you, Paul. And we have Keith joining us from Tennessee. Thank you to all of you. I see a lot more of you dropping in the chat there. So we will circle back with you all later and go ahead and get started here. So we are SevenSignal, the leader in wireless experience monitoring. And we will go a little bit more into depth as to what that means and what our mission is as SevenSignal. So we have a really great topic here today, very interesting and ready to dive into it. We have Introduction to IEEE 802.11bc, Enhanced Broadcast Service. And as I mentioned previously, we are joined by Dave Hallis to lead us today in this presentation. Thank you, Dave. All right, and I'll go ahead and introduce myself again. I'm Kelsey Rizzuto, the marketing specialist at SevenSignal, and we're joined again by Jim Vada, CWNE number 183, and we're really excited to unpack everything that comes with this topic today, and really excited to hear some feedback from the audience. Okay, a couple of announcements before we dive into the topic here. For those of you who have joined us recently, these will all sound familiar, so just hang with me here for a bit here while we run through this. So we do partner with CWNP for every single one of our webinars. So if you're pursuing some kind of certification, you are eligible for continued education credits by watching these webinars. So if you're interested in receiving a certificate for that, just drop us a message or send us a message via email, and we can get a PDF certificate sent to you shortly. We also put out a SevenSignal newsletter every 2 weeks. So if you're interested in signing up for that and receiving that bi-weekly, we will go ahead and drop a link in the chat here as well. So you can get access to all of our webinars, tips, troubleshooting, insights, articles, and more. We also put on a product tour every single Friday at 12 noon Eastern, and you can go ahead and register at go.sevensignal.com/tour. But we don't go too into depth with any kind of product demo on these Wednesday webinars. But if you haven't recently joined us for one of our Friday product tours, highly suggest doing that. We've had a lot of great enhancements and advancements added to Sapphire Eye and Mobileye. So we will go ahead and drop that registration link in the chat here as well, so you can go ahead and register. We also post all of our archived webinars to our YouTube channel. So today's broadcast will be up there later this afternoon, and you can go ahead and watch some of our previous topics that we've covered over the past couple of years. Moving forward here, we also post our slides for every single broadcast to our Twitter account. So if you're on Twitter, go ahead and give us a follow at SevenSignal. But if you aren't active on Twitter, don't have an account, no problem at all. Just drop us a message and we can send those slides over to you per request. And a great reason to follow us on Twitter is because we give away a lot of SevenSignal merchandise. So I'm going to go ahead and read last week's 2 lucky winners. We had David Bernier and Raymond Morano. So congratulations to you two. You should be receiving some SevenSignal merch soon. And to the rest of you online here today, Go ahead and give us a follow if you are on Twitter. And if not, we have a trivia question coming up later that you can possibly win some swag for. All right, we've shown this sneak peek over the past couple of weeks for our webinars, but just wanted to give you a little insight into some recent ROI data from recent IDC research that highlights the business value of SevenSignal's Mobileye. So we are expecting the white paper for this incredibly soon. So just stay tuned, keep an eye out on our website and our socials, and we will get that out to you soon. Another announcement here, again, this will sound familiar to those of you who have joined us, but we have recently been recognized in the Gartner 2020 Market Guide for Digital Experience Monitoring. We are really proud of this to be recognized by Gartner as a representative vendor for Mobileye. So we will go ahead and drop another link for this in the chat here today if you want to access that report. All right, on with the show here. Just to give you a little history on SevenSignal, we were established in 2007 in Helsinki, Finland, and we are now located and headquartered in Cleveland, Ohio. We're really proud of the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily. We have over 200 customers, over 30 partners, and 14 patents. So the technology you see from SevenSignal, you're only going to see from SevenSignal. Additionally, we are certified in over 40 countries and are GDPR compliant. So we take data and privacy very, very seriously for all of our users across the globe. So a lot of major milestones that we've hit along the way here that we are really proud of as SevenSignal. And as I said before, we are the leader in wireless experience monitoring. And we're here because the digital experience matters. So what we do to enhance that digital experience is provide full visibility into the end user experience through our platforms of Mobileye and Sapphire, giving you that outside-in approach. We're also completely AP and device agnostic. So those great tools and technologies that you already have installed, we are incredibly complementary with those as well. So as I said, the digital experience matters. And when you have a poor digital experience, it's usually caused by one of these top 7 Wi-Fi problems here on the left. So typically it's due to congestion, coverage loss, roaming issues, co-channel and radio interference, and more. And how we're able to find and detect those kinds of problems is by running active and passive tests on the edge of the network from the outside looking in, looking for things like packet loss, latency and jitter, throughput, adapter and driver issues, and more, giving you that full scope, full spectrum as to what is occurring in that wireless experience environment. Just to give you a bit more insight as to what makes us so different and sets us apart, is if you look at your typical enterprise LAN infrastructure here on the right, you've already got those great tools and technologies I mentioned previously installed on the network that are giving you useful data, such as your Riverbed, Cisco, Aruba, Appneta, and more. But what we're able to do is pick up where they leave off, giving you full visibility into the user experience with Mobileye. Mobileye can ultimately be installed on any mobile device, from your Zebra scanners, your mobile phones, your laptops, your workstation on wheels, and more. And ultimately, Mobileye can be installed on any Mac OS, Linux, Android, or Windows device as well. And to complement that, we also have Sapphire, which are software-enabled hardware sensors for service level quality and RF visibility. So through this complete suite, you are able to get a full perspective as to your network and what's occurring from the outside looking in. To take it one step further, that LAN infrastructure that you had in the office might not be as useful anymore to you, with a lot of us here on the line working remotely. So with Mobileye, as I said, it can be installed on any mobile device. We're able to gain that visibility into the user experience from those external home networks. So those users who are working from a multi-tenant apartment, your house with other users on the network as well. We're able to give you that insight as to what is occurring in that area as well. And work from home is here to stay as we move into the colder months, and a lot of us are probably working from home more than usual than before. It's incredibly crucial to stay connected. 76% of remote workers are using video conferencing every single day, and 68% of those also have other users on the network in their house or in their unit as well. So as we're all kind of in confined spaces, it's still important and mission critical to stay connected to our work at all times, no matter where we're logging in from. All right, great to give you a little background on SevenSignal. We will go ahead and move forward with our trivia, as I mentioned before, which we give away a lot of swag for. So we have a great question today from Dave that I'm going to go ahead and launch here for you all. Are you guys able to see this?
Yep, we can see it.
Awesome. True or false, IEEE 802.11bc refers to wireless protocols before IEEE 802.11. All right, I see a lot of you dropping in your responses here. We will go ahead and see how everyone does. Give you a few more seconds here, and I am going to close this poll. How did we do, Dave?
Fantastic. That's false. 802.11bc refers to, as the name would imply, that the webinar that they had to do with some work that's going on right now within IEEE 802.11.
Awesome. Well, congratulations to all of you who answered correctly. Thank you for participating. And with that, I am going to go ahead and pass the controls over to our guest presenter today, Dave Hallis. And I'll let him give a little introduction before he dives into this topic today.
Yeah. So for people who don't know me, that I've been involved, I'm a solutions engineer here at SevenSignal and CWNA. So not quite the Jim's level, but just a CWNA. I do have a lot of experience in wireless, whether it's from the product development, being involved with standards, being a solutions engineer, for instance, here at SevenSignal. Some people might know me from past life at Cisco. There, I was recognized as a Cisco innovator. That was primarily because of my work within the security area. I was the task group chair of 802.11i, which was for, if you're familiar with WPA, most everybody knows that WPA and WPA2. That comes from 802.11i. That was such a long time ago. We're on to WPA 3, which was well overdue. I was also involved with, I was basically the first task group chair of 802.11h, which was for a sub 1 gigahertz operation. I was also involved with the formation of the Wi-Fi Alliance, which back then it was known as WECA. It was definitely kind of interesting. And I got a number of patents as well. So that takes us to the topic at hand, which is broadcast traffic in 802.11. And basically the original standard supported broadcast traffic, and that was enhanced by the 82 work that was done in 802.11aa, which was for robust audio video streaming. So then you might ask, well, what more do you need? Well, why exactly did they create this 802.11bc? Well, we'll take a look at some of the use cases and what's going on there. So first, just kind of like get an idea of, well, what does the original traffic look like if you're trying to broadcast traffic? If the broadcast traffic is coming from a client, then what happens is that he doesn't send it out as a broadcast. What he does, that client would do is it would send it directly to the access point, and that part gets acknowledged. It's a unicast packet, and so that, for instance, there's an ACK, and it kind of gets to the access point. And then after that, the access point itself would retransmit it, and that therefore all of the clients should then receive it. And so you might be asking, oh, okay, so you got it covered as far as broadcast traffic. What more word do you want? Well, the problem is that broadcast traffic, it wasn't very reliable. For instance, when it comes out of the access point, then it's only sent once, and so it's not acknowledged as most directed traffic is. So therefore, that even if it's not relayed, if it's something that's coming from the infrastructure and coming out of the access point, it's only going to be sent as one packet. If it gets missed, well, you're not going to see it. A lot of traffic, does come out as broadcast traffic. If you're in the home, there's a lot of discovery protocols that happen, and all these type of discovery protocols. Typically, what they end up doing is they kind of send out a broadcast saying, "Hey, where exactly is something?" If you kind of go off and you're doing DHCP, the first DHCP packet, that comes out as a broadcast packet because you're looking for the server. The other issue with that traffic is that if you have power save going on, if you got one client, then the access point will actually buffer it, and it's going to send it out as a special beacon called a DTIM. And so it's like there's a beacon, and right after it, then that's when that broadcast traffic will come out of the access point. Well, that's also the time where all the clients are going to be trying to access their traffic that's for themselves if they're in power save. And so there's going to be a lot of contention around that time period. So not only is it that it's not retried, but when it does come out of the access point, there is a lot of contention in the wireless space. And so that's going to increase the packet loss. So therefore, you kind of put that all together, and then what you end up finding is that broadcast traffic was not very reliable. And hence, that's why 802.11a came along for enhanced robust audio and video streaming. And so, what exactly is that for? If you're trying to do video primarily, that's being multicast out to a number of clients, that's where things would not work very well with 802.11. So what did that group do that kind of mentioned? There was kind of like two phases to it. One was that the packets themselves are not retried, and then also the time period that they get sent, that it's kind of, there's a lot more contention in that area. So one of the other things that they kind of looked at is that if you looked at the timing of beacons, that they also, wireless LANs, they have a tendency to all align. So there's a number of reasons that those would be increased packet loss. Something that came out before 802.11a, which was 802.11v, brought in a directed multicast service. So what does that mean? That means that if you're a client and you said, hey, I really kind of need this broadcast traffic delivered to me, what would happen is the access point would, it would send it directly to you as a directed packet. So therefore, it would get the retries. And so that would be, one way of improving it. There were a number of proprietary solutions that basically did the same thing as well. That would say, okay, here's a, in this case, I really need this broadcast traffic to kind of get out. So instead of it sending out, just I'll send it as a directed packet to a client to make sure that it kind of gets there. And what's 802.11a, there's a number of things that I've kind of brought. I'm not going to cover everything, but there's a kind of like the overall, there's group cast with retries. And there was two methods that came on when we're talking about the group cast. There's an unsolicited retry. What does that mean? That means, oh, here's a broadcast traffic. Send it like 3 times. And so therefore, well, maybe you'll get one of them. That's one way of kind of addressing it. And then if for people that are familiar with the block act mechanism, that this is another way that the GCR and block act, and basically what's happening here is you kind of want to know if one of those multicast packets was missed. And so therefore you could send a number of them, and you end up kind of knowing, oh, this one was missed, so therefore I'll just kind of send you this one. So those acknowledged retries basically improve the reliability over the unsolicited retry. And then I kind of mentioned to the left, you can kind of see that it scales best with. So the issue with the turning a broadcast or a multicast packet into a directed packet is that kind of works with a small number of clients. But if you've got a large number of clients, then you're just going to be sending like a whole bunch of traffic. So obviously that's not going to scale very well. And then you might kind of look at it and say, well, you kind of mentioned that GCR unsolicited retry, that's basically just saying, well, send it like, for instance, 3 times. And that might scale very well. But, how well does it work in practice? Because there's no guarantee that packet has actually gotten there. And then as far as that, the block act mechanism for GCR, that's kind of like in the middle. That works for a medium number of clients, but not for if you've got a large number of clients. So therefore, there's like the access point has like 3 different mechanisms that kind of take a look at, well, how busy is my wireless network here, and therefore pick the most appropriate mechanism. So that's what was done with 802.11a. So you want more? What kind of use cases are you talking about that are not covered by these existing? You already kind of came up with the original standard. People came along and said, well, there's this broadcast traffic and we need to do additional work. And you got to go off and get we'll talk about the PAR, the project authorization request, and do a bunch of work, kind of put it into the standard. You got to get everybody to agree. And so what exactly are they saying that is not covered by the existing mechanisms? So I'll talk about some of the use cases that were brought up. And basically what we're talking about is like local broadcasting services. If you're in a stadium, you can kind of see that it would be nice if, for instance, that you're able to kind of get different video of the different camera angles and have that kind of sent out to people in the stands if there's something that they couldn't quite see. Usually if I go, I'm sitting in some of the crappy seats, the not so nice seats, and so I might like another video that I could kind of see to actually see what's going on. If I'm on one end of the end zone, I can't see what's going on all the way over there. So having a feed is kind of nice. But that it doesn't, this type of broadcast traffic, it doesn't really kind of fit into the original standard and even the enhancements. For instance, for the current mechanisms, you have to be associated to the access point. Here, that really there is no mechanism nor desired to prohibit the reception. You can kind of think of it as if you had in that arena, if you had a sign up or there's the scoreboard, you want everybody to see it. You don't care who it is, as long as they're able to able to see it. You want them to be able to receive it. There doesn't need to be any encryption going on there. But you do want that the source of that information to be validated. For instance, that is the scoreboard, right? You don't want somebody to inject a false score. Everybody get mad. Hey, that wasn't the way that they actually scored a touchdown. So you do want to validate that information. Then I was kind of mentioned, you don't want, there's the overhead of actually connecting up. If you're, for instance, you're probably familiar with this as you go into like an arena, there's like a ton of access points. And rather than worrying about strictly listening to the traffic one that you're connected to, just like a ton of other access points, as long as you kind of like heard it coming out of one of them, why can't you receive that as valid information? And so therefore, that's kind of what they're looking for, is sort of like these large venues. Also, there's a number of different ones that they kind of come. I just kind of listed this one. They also talked about malls or restaurants. Say, for instance, you're in a restaurant, it'd be nice if you just opened your phone and said, oh, this is what's on the menu, or if you're kind of walking by. Those types of use cases. There are also sort of the some other use cases that kind of came by, which kind of fit into that same category. And if you did want to look at some of these, I listed out the document number from 802.11 that you can kind of look up. The other big use case that hit me was the low power sensor. And here again, most of the time it's like the client doesn't really need to connect. And what they're interested in is not really associating that with these types of sensors, the way they work, it's like any access point. If they receive it, then they want that kind of information sent off to a server. And so therefore it doesn't, and it's not, it doesn't really work the way that 802.11 works. If you kind of think of what does 802.11 normal traffic work like, it's you connect up to the access point, and then your data is transparently bridged onto the network. And here, this is not quite the same thing. These sensors, they want to kind of have that the access point receive it, and they don't want that traffic transparently bridged. they want it sent to directly to a server that's going to handle that traffic. And also there might be some other information that the access point might add on to that information. For instance, if the sensor kind of sends something out, then the access point might want to say, oh, this is the time that I received this sensor packet, and also the signal strength that I received it, or for instance, that the access point itself received it, I should say. Tack that onto it. And there might be some other information as well for sensor networks that would go on. So it does work differently. It's not strictly like a data packet bridging mode. It is working a little bit differently. And there's that kind of added in the use case. So there's these two different use cases that are kind of coming into this work here. And it didn't really quite fit into the way that 802.11 works now. But that they're kind of saying this would be nice, that this would be kind of open up some other market opportunities. Somebody might ask, well, where exactly is this? Is it available today? No, it's that these things do take a certain period of time. You know, we're talking years, not days or weeks or months. And exactly where this is one of our other webinars that we did on standardization processes, and put it in here because I thought it'd be useful. And we'll kind of see that this is more on the beginning side of things. That there was a project authorization request approved. So what ends up happening is if you say you have some work that you want to do, you kind of have to kind of go and say, oh, you got to get buy-in by the rest of the group and say, okay, let's fill out this form that says that, you know, project authorization request. Now you don't just jump to filling out that form. You kind of have to convince people, so you kind of have to kind of do some presentations, for instance, those use cases, and then discuss it and socialize it and say this is why that this work is needed. And then when you actually create the PAR form, you have to kind of get, you got to get buy-in from the group, from 802.11 itself. And then from there, then it has to go up the process from the, besides the 802.11 working group, there's the 802 chairs that have to kind of sign into that executive committee. And then it has to kind of go up to IEEE, and IEEE has to approve it as well to say, yes, we'll let this work proceed. That has been done. So that whole process of getting things started has been done. And that's where then once the IEEE has approved it, they create that task group has been actually officially created. So that's 802.11bc. Within there, then now that's a task group within 802.11. What they have to do is kind of come up with a draft, and they have created actually the first draft. So that's definitely a big milestone. And once they kind of there's a lot of work to kind of get everybody to go through, get approval for it. Now, I didn't kind of get into actually describing the actual draft here. Because when you come up with the first draft, there's obviously everybody within 802.11 that are voting members, they got to vote on it. It's not only just like optional for them to, they must vote on it. And so if you've got like a number of voting members, like I forget what the exact attendance is, but it's like around 500 or something like that, 500 people voting on it, you're going to see a lot of comments come in. And, you know, it's the exact approach that they've taken. Is that the way it's going to end up at the end points? And it still remains to be seen. But they have done, looking at the draft, they have done a lot, you know, a lot of work, and it's some good work on it. Then it has to go through a process called sponsor ballot. After that, then it kind of goes into standards board approval, and then it gets published. And so I kind of mentioned where this is actually from, down below. So what's the timeline? When I made these slides, I think I should have made this a little bit bigger. So it might be a little bit of an eye chart. That's basically what, now, first off, the thing I want to mention, this is an educated guess. It's been around for a while, so they get a sense of, okay, this is how long this type of work took. So they'll kind of look at other groups and say, oh, this is kind of how much work we're kind of thinking about. So they'll kind of come up with a guess. And they're talking about RevCom basically September of 2022. So it's actually not too far off. I mean, it's 2020. When I say not too far off, you might say that's like 2 years from here, Dave. Actually, in the standards, IEEE 802.11 standard timelines, that's not that too far off. So what's the scope? And so the most kind of, usually I find the most important thing on the project authorization request, there's something called the scope and what it is that you could actually change. For instance, there is no mention of a PHY on the scope. So therefore, if somebody said, oh, well, this would work much better if we came up with this new radio, then somebody will come along and say, you didn't put that on your scope. Yeah, that suggestion or comment is out of scope, and so therefore would be shot down. And so it kind of says, as we're kind of talking about it before, which is that they do kind of mention no association between the transmitter and receiver. And then they also kind of mention there is origin authentication for the protection for the broadcast data frames. So those are kind of the two things. I mean, they do kind of mention that you can be associated. I guess is I'm not sure how much is needed there, but there is, if you look at that first draft, there is some other information that has to go into advertising of services, which are kind of optional, but nevertheless, it's there. So that's the power scope. The other thing I kind of wanted to mention was earlier on in the slides, I was talking about the different work that was going on within, for instance, 802.11aa for increasing the reliability of multicast traffic. Well, what about low power sensor activity in 802.11? There has been a lot of activity. For instance, I kind of mentioned that as the original chair of 802.11ah. Definitely that was targeted at low power sensor. And then also that, more recently, as you're probably aware, is 802.11ax has these off-DMA resource units. I kind of think of them as like sub-channels. And the advantage there is it's going to help you save power and a more efficient use of the channel. There's a lot of hope there. I'd like to see it actually come out. I'm not sure how well it's worked so far, but the potential is there. And then also we kind of talk about power saving mechanisms. AX and AH, they definitely, there's the target wait time. There's a bunch of things that are kind of coming in to save power. Then even right now, that the work is going on for 802.11ba, which was the wake up radio services, which we did another webinar on. And then now you can look at this enhanced broadcast services for the IoT use cases. So you can kind of see it, and I think this kind of relates to some of the things that last week's webinar, that all use cases don't seem to fit within 802.11, but there's definitely a lot of work that's kind of going on in this area. So that's definitely kind of coming up of some interest. So with that, I want to turn it back over to you.
Great. Thanks, Dave. That was really cool. Thinking about the unassociated Wi-Fi client getting broadcasts from nearby APs, that's really interesting, and it opens up a lot of possibilities for really cool use cases like the ones you described. It also is kind of, if you think about like a mall, what if every shop that you're within radio distance of is trying to bombard you with coupons and marketing and things like that? It's interesting to see how, what the balance between, yes, send me these kind of unsolicited notifications versus how do I put some filter on that to make it, useful and not just noise.
Yeah, actually, that's a good point, Jim. That that is one of the use cases that kind of mentioned. I didn't mention all of that broadcast. I kind of mentioned the stadium use case, but because I kind of saw that the walking through the mall kind of fits in the same. The mechanisms would end up being the same.
Yeah.
Now, obviously, I agree with you. A lot of noise. It's like billboards on the highway. Do I really want to look at all these? And I do see that there's a capability of, if you're getting this on your phone, you should be able to be selective about just show me this type of stuff.
Yeah, kind of an opt-in kind of model.
Yeah.
So we have some great questions from the audience today. Glenn asks, just to clarify, was GCR brought by 802.11v as well? Was that 802.11v or 802.11aa?
802.11a brought in that, I forget the actual ones it had to do with. 802.11b brought in the turning the multicast into a directed packet. And then the overall mechanism, since that 802.11, we're talking, I'm sorry, V brought in the directed multicast. AA brought in the GCR with the two additional methods, one being that basically the unsolicited retry, so basically send it like 3 times. And then the other method, which had to do with using the block act mechanism. And then likewise, I didn't kind of get into the entire detail, gory details. There is a lot of other information. For instance, being able to set up, when you're doing QoS, you'd kind of set up like an agreement about how that you'd want to have the different options run, and that negotiation I didn't really kind of cover inside of the slides because I thought that would be a little bit too much to try to get through in this type of venue, but there is a lot more there. So that kind of helps as far as where does it come from.
Cool. Arjan has a good question here. Can this IoT use case of .11bc somewhat be compared to the connectionless CCX protocol from Cisco used in Stanley AeroScout Wi-Fi tags for RTLS?
Yes. That's a short answer. Now that that is exactly the use case that they're kind of looking at. Now, if you were to ask how similar are they, the similarities are there's no association, that the mechanisms that you're asking about now are currently proprietary, so they're not covered by a standard. I won't get into any saying how proprietary stuff works. I'll just say what was read in the standard. In the standard, they're talking about that type of traffic where you send data packets to the access point and you're not associated. If you're familiar with the action frames, they're talking about using those type of action frames. So you might find out, well, there might be some type of difference between how some of those proprietary systems work, but it's the same type of use case. So definitely falls into that same area.
Yeah, cool. Yeah, a good comparison too might be between other wireless protocols for IoT like LoRaWAN and Sigfox. Those are both designed so there isn't any authentication with access points, or they call them gateways in those protocols. If a gateway hears a sensor transmitting, it picks up the packet and forwards it. And the authentication and encryption happens actually just between the application server and the sensor itself. So the gateways just hear traffic and forward it, hear traffic and forward it. Doesn't matter whose gateway it is, it'll just get forwarded along.
Yeah, the other thing that I could have mentioned is that it's the type of information that you're interested in might be even like when it's typical 802.11 traffic, all you're interested in is the payload that device is sending. Here, that might not even be all that interesting. What you're interested in is other information. For instance, when the access point received that packet, what was the signal strength that it heard it at? What time was it? And that kind of gets sent off to the server. It's not, the use case is definitely different than the bridging type of application of the data packets versus the sensors. That it might be some of the information that's kind of sent over the air, but it might actually be some other metadata that you're interested in.
Yeah. Good question from Glenn here, really kind of about how the protocol works, but in the context of 802.11bc, how does the AP know where to send the packet from an IoT device?
Good question. There were some type of information that was when you basically you'd have to do some kind of configuration on your system. Now the intent is that what they want is you've got some headless device, some sensor to there be no configuration. You've got it, you put it up. You don't have to worry about, oh, did I set the key right, or, you know, setting up credentials, anything like that. You're probably used to that from those types of sensors. There is, when I talked about from the IoT case, the sensor sends some data in a action frame. There is some type of what they call optional exchanges that could happen before that. If you're familiar with like the gas protocol and the ANQP, which has to do with, oh, I'm kind of look at what are these pre-authentication? I want to know about the services that are available.
That old Hotspot 2.0 stuff. Yeah, I remember that.
Yeah, they're building on that, which would be optional. You could kind of say, oh, I'm this type of sensor. I'm looking for this type of a server on your local system. You know, you might change that. That's say, oh, well, this host name is, you know, obviously different than some other host name, or it might be going out to the internet. So it'd be kind of along using those same type of mechanisms.
Yeah, another question here from Glenn. Will 802.11bc be a more robust solution than casting via multicast DNS? I think it's probably different use cases there, Glenn. I think multicast DNS is really just used for device discovery, and then after that, the traffic between devices is unicast. What do you think, Dave?
Yeah, that the talk about MDNS in a large stadium. MDNS was really set up for like houses, and that's, you know, how well does that? And we're really kind of talking about something different. That's the availability of the services, as we were just kind of talking about, that you'd find out via something very similar to that Hotspot 2.0, where that you could kind of query the access point even before the association for what kind of services are there that are on here, and if I wanted to send something, you know, where would it kind of go off to? That there are some optional exchanges that would happen beforehand, which is maybe a bit. So it's definitely different than MDNS.
Yeah, and just, you know, thinking through that querying process, that could be the point at which, you know, you decide on what traffic you actually want to receive, or just discard in that busy mall situation where you might have broadcast traffic coming from all over the place.
Right.
One last question, and it's always my favorite question about new stuff from the IEEE and Wi-Fi Alliance is, will this be optional or mandatory, or you know, certainly something that's still in development, but what's your take on that, Dave?
I think that's a fantastic question. And that really what kind of happens, and I know Jim would kind of talk about some similar topics along these lines, is if you looked at it, it's at 11AA, I think I looked at it, there was no, as far as I know, there's no certification within Wi-Fi Alliance for that. What it really kind of comes down to is that's market forces. Kind of like the line in the movie, it's like, if you build it, will they come? That's when we looked at the Wi-Fi 6E, there was a lot of work that kind of went into that to make that opportunity happen. It's not like it just happened overnight. And so therefore, now the question is, you know, will it take off? Will it kind of move forward? For that, when I look at the IoT space, I kind of look at it, and you kind of, you're welcome to look at some of those use cases and then say, well, who's actually putting in those use cases? And who, like, of the efforts that I kind of mentioned, who's kind of driving some of those efforts? Then you could kind of find the companies that were definitely interested in it and were willing to have people actually work on it. Because there's definitely something that, you know, it's not like it just happens. Companies have to put in resources to actually do work on that standardization process well before that the market actually accepts it. And I agree with, for instance, last week's webinar when Lee Badman was on. It's like you kind of look at some of the use cases, and you might find that 802.11 there isn't quite a good fit. And so you end up having some very smart people saying, well, what would it take to get it to fit? And even if you got it to fit, is the market already set? Or, is there room for 802.11 kind of have an opening into these areas? I can't come up with any guarantees that it's going to happen. You can just see the efforts that are going into it, though.
Cool. All right, Dave, thanks. Great webinar.
All right, a lot of great questions today. Thank you so much to everyone who dropped a question in here today. We love hearing feedback from the audience and really kind of getting to dig a little bit deeper into these topics. So that concludes today's webinar. Thank you, Dave, for joining us again. We love having you on every month or so to go into a new topic here. And thanks again to Jim for joining us today. And of course, thank you to all of you for giving us 45 minutes out of your workday to dive into this topic together. So we hope to see you all next week and have a great rest of your day. Thanks, everyone. Bye, Dave.
Thanks, Dave.
Bye, Jim.
Thanks, Kelsey.
Bye, Jim. Bye, Kelsey.